So now let us try to apply the same idea on the second graph. So if we assume that this vertex has source, then the cycle can be generated by traveling from 1 to 2 or 1 to 5. So if you start from 1 to 2, 2 to 3, 3 to 4, and then 4 to 2, so stuck up 1 to 5, 5 to 2, and 2 to 3, and 3 to 4, but it is not coming back to 1. So it is clear that from both these edges, there is no cycle possible from vertex 1. So from vertex 1, there is no cycle in this graph, and same will be applicable to all the vertices. So suppose I take vertex 3, so 3 to 4, 4 to 2, 2 to 5, 5 to 1, 1 to 2, and so this is again visiting vertex 2 twice. So that is not permissible. So the same concept can be proved that if there is no cycle from a vertex, then there will not be any cycle from any other vertex. Now let us try to understand the algorithm. So as it is a backtracking concept, so every backtracking algorithm will be of two parts. One is basically passing the value of an index, and two is finding the value for the index. So what is this? Basically, we are trying to create an array X, which will have some vertex as starting vertex, and we will travel to all intermediate and will end back to 1. So this is the output array, which is represented by variable X, and it will have one vertex as starting, same vertex as ending, and all the intermediate vertices will be remaining vertices of the graph. So while writing these vertices in this array, it is essential to check whether the constants are satisfied or not. So what are the two constants? One is if you are visiting a vertex, let us for example, if I am starting from vertex 1 to 3 and then 3 to 4, then there must exist an edge between 3 and 4. That is a compulsion. And if I am starting from vertex 1, vertex 3, vertex 4, 5, 6, then another constraint is if I have already visited a vertex, then it should not be visited again. So if a vertex is visited, then it should not be visited. And when the vertex is to be visited, there should be a connectivity. So first is visited vertex should not be visited again. Second is new vertex should have connection with the previous vertex. For example, if you are visiting VK, so you must have visited VK minus 1. So there must be a connection between the two vertices. And lastly, when you are visiting, for example, if there are n vertices in the graph, then there will be one vertex as source and all n vertices, all n minus 1 vertices will be intermediate, and last vertex will be again source. So whatever I am writing at location, which is considered as last but one location of the cycle, then it should have connection with the source. For example, look at here. If I am writing at, let us take this cycle 1 to 2. So if I'm writing 3 here, then I must ensure that this 4 and 3 are connected and 3 and 1 are also connected. So this condition is only for last but one vertices or the nth vertex of the graph. Otherwise, this condition is not essential. So that's why we are just trying to check what is the idea. Like when we are talking about a normal concept, we will pass a vertex. So next value k means we are passing a index of that vertex to be checked. For example, if I am talking about some location, so already if I have the cycle like 1 to 8, okay, so 1 to 8 is already generated. Then from 8 I can go to 7. So I will pass, this becomes my index 1, 2, 3, and I'll pass k equal to 4. So I'm passing k equal to 4. I'll check k equal to 3 for connection and k equal to 1 to 3 for repetition. Very simple. So next value k will do this operation, or rather three operation. What next value k will do? One, it will check the connection between vertex at k equal to 4 and vertex at k equal to 3. One, it will check if the vertex which we are planning to write here is already used or not. And if k equal to n, it will check connection with 1 and the previous also. So in case if it is not satisfied, then x of k will be 0 and it will return the control to the main program. If k equal to n, then we'll write the array. Otherwise, we'll continue the process of Hamiltonian cycle by passing the next vertex k plus 1. So initially we are passing k equal to 1, then k equal to 2, then k equal to 8. Slowly. Okay. So how the constraints are checked? First, repeat. And since x of k at every location is 0, so it will first check x of k equal to 0 plus 1 mod 9. Why 9? Because number of vertices are 8. So this n equal to 8. So mod 9 will create 1 here and will continue. So since it is not equal to 0, then will not return. Now look at this idea. If we are writing at kth position in x, so it will be considered as x of k. And when we are writing at x of k, it means that x of 1 to k minus 1 is already occupied or already having the values. So only thing is to check whether x of k minus 1 and x of k are connected or not. If they are connected, then we'll check for the repetition. So if they are connected, then a for loop is operated here. And this for loop will run from j equal to 1 to k minus 1. Why 1 to k minus 1? Because we are writing at vertex k. And if the value of x of j is equal to x of k, then break. And if it is not like this, then j will become k. So this loop will end with j equal to k because it is running up to k minus 1. So when it will end with j equal to k, it means that there is no break executed and nowhere there is repetition. So there is a connection and no repetition. Okay. One more condition, like if k is less than n, no problem. No repetition, no repetition and connection. No problem for k less than n. But there is a problem with k equal to n. So we will check a connectivity of x of n and x of 1. And if it is not equal to 0, then we will return. So this OR will permit to operate for all values k less than n with connection and with no repetition. One is connection and one is no repetition. Connection with the previous and no repetition from 1 to the current. So for example, if I say here 12876, so let us say 12876, okay. Already I have 12876. Now what I can write here, I'll try starting with 1. Cannot write, already there. 2, cannot write, already there. This will not allow us to enter. 3 I can try. So I can try 3 because 3 is not used, but 6 is not connected. 6 is connected with 3. So we can continue with 3 here. And if we can still find a cycle, that is accepted. If no cycle, then we continue with 4, no cycle, continue with 5, and so on. So in this way, there are two main parts of this concept. Check whether the two vertices, that is vertex at k and vertex at k minus 1, are connected. If they are connected, then check whether 1 to k minus 1 is already having the same index, same value which is written at k. And if k equal to n, then check whether this n and 1 are connected or not. 1 means the source vertex. So hope you understood this idea and the logic of Hamiltonian cycle. Thank you very much.